Imagine a world long before our modern cities, a time when humans shared the Earth with other ancient relatives. Around 41,000 years ago, something truly remarkable happened. Our planet's protective magnetic shield, a force we cannot see but which keeps us safe, began to weaken dramatically. For the people living then, this change would not have been invisible. The skies above them would have transformed into a canvas of strange and dazzling lights. Auroras, those beautiful shimmering curtains of green and purple light that we normally only see near the North and South Poles, would have danced across the night sky in places they had never been seen before. It must have been a sight of both wonder and perhaps great fear for our ancestors. This was not just a light show. The weakening of the magnetic field meant that the Earth was losing its primary defense against powerful forces from space. Harmful radiation from the sun and from distant cosmic events began to pour into our atmosphere at much higher levels than usual. This invisible threat would have made the world a more dangerous place for all living things. The sun's rays would have felt stronger, burning skin more easily, and the very air would have carried a hidden danger. For early humans and their Neanderthal cousins, this new and challenging environment would have demanded adaptation. Surviving this strange and difficult period would have depended entirely on their ingenuity and their ability to change their way of life. The world they knew was being fundamentally altered by forces far beyond their control or understanding. The familiar patterns of day and night, of safety and danger, were being rewritten. This period, which scientists now call the Laschamps Excursion, represents a fascinating chapter in our planet's history. It was a time when the heavens seemed to descend upon the Earth, bringing with them both breathtaking beauty and unprecedented peril. The story of how our ancestors navigated this crisis is a powerful testament to human resilience. It is a story that has been pieced together from clues left behind in ancient caves and buried deep within the Earth's own memory. Understanding this event takes us back to a pivotal moment in our own evolutionary journey. It was a time of great change not only in the skies but also on the ground. Modern humans, Homo sapiens, were spreading across Europe, a continent they shared with the Neanderthals, a species that had thrived there for hundreds of thousands of years. The environmental pressures created by this cosmic event may have played a crucial role in the intertwined destinies of these two groups. By looking back at how they faced this challenge, we can learn a great deal about what it takes to survive on a planet that is constantly changing, and we can better appreciate the long and difficult road that led to us. Our planet Earth behaves like a giant magnet. It has a North Pole and a South Pole, and an invisible magnetic field that surrounds it like a protective bubble. This field is incredibly important because it shields us from the solar wind, a constant stream of charged particles flowing from the sun. But this field is not always stable. Throughout Earth's long history, it has weakened, shifted, and even completely flipped, with the North Pole becoming the South Pole and vice versa. The Laschamps Excursion, which took place around 41,000 to 42,000 years ago, was one of these periods of great instability. It wasn't a full reversal, but something almost as dramatic. During the Laschamps Excursion, the Earth's magnetic field weakened to a tiny fraction of its normal strength. Some scientific models suggest it dropped to less than 10% of what we experience today. At the same time, the magnetic poles themselves began to wander erratically across the globe. The magnetic North Pole, instead of staying near the geographic North Pole, drifted far to the south. This meant that the planet's protective shield became thin, fragmented, and weak. It was as if the Earth had temporarily lowered its defenses, leaving itself open and vulnerable to the harsh environment of space. This period of geomagnetic instability lasted for several hundred years, a long time for the people and animals living through it. We know this happened because of the clues left behind in rocks and sediments. When volcanic rocks cool or when sediments settle at the bottom of oceans and lakes, tiny magnetic particles within them align with the Earth's magnetic field at that moment, just like tiny compass needles. By studying layers of these materials, scientists can read the history of our planet's magnetic field, chapter by chapter. The layers dating back to around 41,000 years ago show this clear and dramatic signature of a weak and wandering field. This geological record provides the definitive evidence for the Laschamps Excursion, allowing us to pinpoint when it happened and understand its scale. For the people of the Stone Age, the world was their home, their provider, and sometimes their greatest adversary. They had no scientific instruments to tell them that the planet's magnetic field was failing. All they would have known was that the world was changing in unsettling ways. The brilliant light shows in the sky would have been the most obvious sign, a constant reminder that something was different. But the more significant changes were invisible. This event was not just a geological curiosity, it was a profound environmental crisis that would have directly impacted the health, behavior, and ultimate survival of everything living on the planet's surface. The Laschamps Excursion set the stage for a major test of endurance. The Earth's magnetic field, also known as the magnetosphere, acts as our planet's first line of defense. It deflects the vast majority of charged particles that make up the solar wind and cosmic rays, which are high-energy particles originating from outside our solar system. When this shield weakened during the Laschamps Excursion, it was like opening a gate and allowing these harmful intruders to rush in. The magnetosphere, which normally extends tens of thousands of miles into space, shrank and became patchy. This allowed dangerous radiation to penetrate deeper into our atmosphere than ever before, reaching all the way down to the surface where people lived, hunted, and raised their families. One of the most immediate and visible consequences of this weakened shield would have been the spectacular auroras. These lights are created when charged particles from the sun collide with gases in our atmosphere. Normally, the magnetic field funnels these particles towards the poles, which is why auroras are typically seen only in the Arctic and Antarctic regions. But with a weak and wandering field, these particles could enter the atmosphere all over the world. The skies over Europe, Africa, and Asia would have been filled with shimmering, colourful lights night after night. It would have been a truly global and perhaps terrifying spectacle for our ancestors, who had no way of knowing its scientific cause. Beyond the mesmerizing lights, there was a more serious threat, a massive increase in radiation. The surface of the Earth was bombarded with more solar energetic particles and cosmic rays. This type of ionizing radiation can damage living tissue and DNA. For early humans, this meant a higher risk of severe sunburn, skin damage, and vision problems from the increased ultraviolet radiation that made it through the altered atmosphere. More insidiously, this radiation could have had long-term health effects, potentially increasing the rates of cancer and causing genetic mutations. The very air they breathed and the ground they walked on would have become more hazardous to their health. This dramatic change in the environment would have affected every aspect of life. Animals would have been impacted just as much as humans. The increased radiation could have disrupted their navigation, health, and reproductive cycles. For the hunter-gatherer societies of the time, this would have meant that their food sources might have become less reliable. The world had become a fundamentally more dangerous place. Survival was no longer just about finding food and avoiding predators. It was also about finding ways to protect oneself from an invisible enemy that came from the sky. This period of intense space weather was a challenge unlike any they had faced before. Living on an Earth with a failing magnetic shield would have been incredibly difficult. The sun, normally a source of life-giving warmth and light, would have become a source of danger. Without the strong protective layer of the magnetosphere and the resulting changes to the atmosphere's chemistry, much more harmful ultraviolet radiation would have reached the ground. Spending too much time out in the open during the day could have resulted in painful and severe sunburns in a very short amount of time. People's eyes would have been at risk of damage, and the long-term consequences of this exposure would have been serious, affecting people's ability to hunt and gather food. The health risks would have extended beyond just sunburn. The constant bombardment of cosmic and solar radiation can damage the very building blocks of life, our DNA. This can lead to a higher incidence of cancers and other illnesses. Perhaps even more critically for the survival of a species, it can affect reproduction. The increased radiation could have led to more birth defects and a higher rate of infant mortality, placing enormous strain on small nomadic populations. Every healthy child born was essential for the continuation of the group, and any environmental factor that threatened this would have been a grave danger to their future. Our ancestors faced a daily, invisible threat to their well-being and their very existence. The psychological impact of these changes must have also been immense. The night sky, once a familiar map of stars, was now filled with strange, dancing lights. These auroras, visible far from their usual polar homes, could have been interpreted as omens, messages from spirits, or signs of an angry and chaotic world. The constant uncertainty and the visible transformation of their environment would have been deeply unsettling. For people who lived in such close connection with the natural world, these changes would have signaled that the world was out of balance. This psychological stress, combined with the physical dangers, would have made life during the Laschamps Excursion a time of great hardship and fear. In this new and hostile world, the old ways of life may not have been enough to ensure survival. Staying out in the open for long periods was no longer safe. The strategies that had worked for thousands of years, following herds across open plains, for example, now carried a new and invisible risk. Our ancestors were faced with a stark choice: adapt or perish. The groups that were able to recognize the new dangers and innovate, changing their behavior to protect themselves and their children, were the ones who would have had the best chance of making it through this difficult period in Earth's history. The stage was set for a remarkable story of human adaptation. Faced with this dangerous new environment, early modern humans, Homo sapiens, did what our species does best: they adapted. The archaeological record from this period shows a remarkable shift in human behavior, suggesting that they found clever ways to protect themselves from the increased radiation. One of the most significant changes was an increased use of caves and rock shelters. While caves had always been used for shelter, evidence suggests that during and after the Laschamps Excursion, people began to spend much more time living deep inside them. A cave provides a thick, natural barrier of rock, offering excellent protection from the harmful rays penetrating the atmosphere. It was a simple but highly effective strategy. Another key innovation appears in the clothing they made. Archaeological sites from this time show a rise in the number of tools like bone needles and awls. These are the tools needed for sewing and tailoring. This suggests that instead of simply draping themselves in loose animal hides, humans began to create more complex, fitted clothing. Tailored garments that covered more of the body would have provided a crucial layer of protection against the sun's harsh UV radiation. This would have allowed them to move and hunt more safely in the open when they had to leave the shelter of their caves, giving them a significant advantage in this challenging new world. Perhaps the most fascinating adaptation was the widespread use of red ochre. Ochre is a natural clay pigment rich in iron oxide, and it creates a brilliant red colour. For a long time, archaeologists thought its use was purely symbolic or for ritual art. However, new research strongly suggests it was also used as a form of sunscreen. When mixed with a base and applied to the skin, ochre is highly effective at blocking UV radiation. The archaeological record shows a dramatic increase in the collection and use of ochre around 41,000 years ago. It seems our ancestors discovered that painting their skin with this red pigment offered real protection from the sun, a kind of prehistoric sunblock. These three adaptations, seeking shelter in caves, making better clothing, and using ochre as a skin protectant, show an incredible level of awareness and ingenuity. Our ancestors were not passive victims of their changing environment. They observed the effects of the increased radiation, likely noticing the painful sunburns and other health problems, and they actively developed new technologies and behaviors to counteract them. These innovations were not just clever tricks, they were life-saving strategies. They allowed Homo sapiens to continue to thrive and survive in a world that had suddenly become much more hostile, showcasing the flexibility and creativity that has long been a hallmark of our species. During this same period, Europe was also home to another human species, the Neanderthals. They were a hardy and intelligent people who had successfully lived on the continent for hundreds of thousands of years, surviving multiple ice ages. They were skilled hunters, capable of taking down large game like mammoths and woolly rhinos. They made sophisticated stone tools and had their own complex social structures. When the Laschamps Excursion began, the Neanderthals faced the same environmental challenges as the newly arrived Homo sapiens. The skies above them would have filled with the same strange lights, and their bodies would have been exposed to the same dangerous radiation. However, when we look at the archaeological record, we see a different story for the Neanderthals. There is far less evidence to suggest that they adopted the same protective behaviours as modern humans. While Neanderthals certainly used caves, they do not seem to have increased their use or occupied them as intensively as Homo sapiens did during this specific time. Their toolkits show that they continued to make the same types of tools they had been making for millennia. There is no evidence of the needles and awls that would indicate the production of tailored clothing, suggesting they likely continued to wear simpler, looser hides that offered less protection from the sun. Furthermore, while some Neanderthal sites show limited use of pigments like ochre, it is nowhere near the scale seen at Homo sapiens sites from the same period. It doesn't appear to have been a widespread or systematic practice for them. It seems that for whatever reason, the Neanderthals did not develop, or at least did not widely adopt, the same suite of protective innovations. They largely continued to live as they always had, relying on the strategies that had served them so well for countless generations. In a stable world, this would have been a sound approach, but the world of the Laschamps Excursion was anything but stable. This difference in response is crucial. The Neanderthals were not less intelligent, but their culture may have been more traditional or less flexible when it came to rapid innovation. They were highly adapted to a specific way of life, and that very adaptation might have made it harder for them to change course quickly when faced with a completely new type of threat. Their apparent failure to adapt to the high radiation environment would have left them more exposed, more vulnerable to its harmful effects, and at a significant disadvantage compared to their more innovative human neighbours. This lack of adaptation would have added another layer of stress to their already challenging existence. The period of the Laschamps Excursion was a critical time, as it was one of the last moments when two human species, Homo sapiens and Neanderthals, coexisted in Europe. The different ways they responded to this cosmic event may tell us something important about why one group survived and the other did not. Modern humans, with their tailored clothing, their extensive use of ochre sunscreen, and their preference for deep cave shelters, were better shielded from the relentless radiation. This would have meant they were healthier. They would have suffered fewer burns, had better overall health, and likely had more successful pregnancies and healthier children. In a world of marginal gains, these advantages would have been enormous. In contrast, the Neanderthals, who seemingly did not adopt these protective measures, would have borne the full brunt of the environmental stress. Spending more time in the open with less effective clothing and no sunscreen would have exposed them to dangerous levels of UV radiation. This could have led to more health problems, reduced their ability to hunt effectively, and lowered their reproductive success. Even a small drop in birth rates or a small increase in infant mortality can be devastating for a small population over time. The Neanderthals were already living in small, scattered groups, and this added pressure could have pushed them closer to the edge. It is very important to be clear, the Laschamps Excursion did not kill off the Neanderthals on its own. Their extinction, which happened around 40,000 years ago, shortly after this event, was a complex process with many contributing factors. They were also dealing with a rapidly changing climate and increasing competition for resources from the growing populations of modern humans. The geomagnetic event was not a single fatal blow. Instead, it should be seen as another major stressor, a very powerful one, added to a pile of existing challenges. It was another weight on a species that was already under immense pressure. The story of this time is therefore a tale of resilience and vulnerability. Homo sapiens demonstrated a remarkable ability to innovate and adapt their culture and technology to meet a new and deadly threat. This flexibility may have been their key advantage. The Neanderthals, while strong and well adapted to their traditional world, may have lacked this capacity for rapid cultural change. In the end, the group that was better able to shield itself from the dangers of a changing planet was the one that thrived. The Laschamps Excursion may have been a critical test that, through the different responses it provoked, helped to shape the final outcome of this long chapter in human history. The incredible story of how space weather affected our ancestors was not uncovered by one type of scientist alone. It is a perfect example of what can be achieved when experts from different fields work together. This breakthrough came from a collaboration between geophysicists, who study the Earth's physical processes, and archaeologists, who study the human past through the things people left behind. For a long time, these two fields worked separately. Geophysicists studied the history of the Earth's magnetic field, and archaeologists studied ancient tools and bones, but they did not always connect their findings. This new research shows how powerful it can be when they do. The geophysicists used sophisticated computer models to recreate the conditions on Earth during the Laschamps Excursion. By feeding data from the geological record into a program called the Space Weather Modeling Framework, they were able to simulate what the planet's weakened magnetic shield would have looked like. Their models showed exactly how the magnetosphere shrank and how the auroras would have spread across the globe. Most importantly, they could calculate how much extra radiation would have reached the surface in different parts of the world. This gave them a detailed map of the environmental danger zones 41,000 years ago. With this environmental model in hand, the team then turned to the archaeologists. The archaeologists had spent decades carefully excavating sites across Europe, building a detailed picture of where and how early humans and Neanderthals lived. They knew which sites showed evidence of ochre use, which had bone needles, and which caves were most intensively occupied. By laying the archaeological data on top of the geophysical map, they saw a stunning correlation. The places where humans showed the most significant behavioral changes, the increased ochre use, the tailored clothing, the deep cave dwelling, matched up with the areas that the models showed were exposed to the highest levels of radiation. This cross-disciplinary approach provides a much richer and more convincing picture of the past. Without the geophysical models, archaeologists might have struggled to explain why these cultural shifts all happened at the same time. Without the archaeological evidence, the geophysicists would have known that a magnetic event occurred, but they would have had no idea how it might have impacted life on the surface. By combining their knowledge, these scientists were able to connect a cosmic event to the daily lives of our ancestors. It is a powerful reminder that to understand our own history, we must also understand the history of our planet. Studying an event that happened so long ago might seem like a purely academic exercise, but the story of the Laschamps Excursion holds important lessons for us today. The Earth's magnetic field is not a constant, unchanging force. Right now, in the 21st century, scientists have observed that the field is weakening again. It has lost about 10% of its strength since the 19th century. At the same time, the magnetic North Pole is drifting away from Canada and towards Siberia at a rapidly accelerating pace. These are the same kinds of signs that preceded the Laschamps Excursion 41,000 years ago, reminding us that our planet's magnetic shield is dynamic and unpredictable. We do not know if these changes signal that another excursion or a full reversal is imminent. These events are rare and happen over long timescales. However, understanding what happened during the Laschamps event helps us to appreciate the potential risks. A similar event today would pose a colossal threat to our modern, technology-dependent civilization. Our society is built on a fragile infrastructure of satellites for communication and GPS, and vast power grids that distribute electricity. A major geomagnetic storm, caused by a weakened shield, could knock out satellites, disrupt communications worldwide, and cause widespread blackouts by overloading power grids. The danger is not just to our technology. Astronauts in space would be exposed to life-threatening levels of radiation. Even air travel could become more hazardous, as passengers and crew on high-altitude flights would receive higher radiation doses. While our buildings and clothing protect us from most UV radiation, a significant weakening of the magnetic field and its effects on the atmosphere could have long-term health implications for all of us. The story of our ancestors shows that such events can and do happen, and they fundamentally change the environment on the planet's surface. We are not immune to the effects of space weather. Therefore, the tale of our ancestors' ingenuity is both a warning and an inspiration. It warns us that we live on a planet with a powerful and sometimes volatile connection to the cosmos. We must take the threat of space weather seriously, investing in research to monitor the magnetic field and developing strategies to protect our vulnerable infrastructure. But it is also a story of hope. It reminds us that humanity has a long history of facing unprecedented environmental challenges and surviving through innovation and adaptation. By learning from the deep past, we can better prepare for the challenges of the future, ensuring that we are ready for whatever our planet and the space around it may have in store.